Okay, so now let's do some lens problems. We'll do one problem with concave, and then the next video will be one with convex lenses. All right, so a concave lens is one that has both sides that cave in. All right, so this is also known as a diverging lens. It's thinner in the center of the lens than it is out at the edges. So it has a focal length of 32 centimeters. And since this is a diverging lens, you should just remember by definition, the focal length is negative. So a diverging lens is the same as a convex mirror. The image is always virtual. It's always upside right. And it's always smaller than the object. So we can remember for this, we know it's the simplest case because we know what we're going to get. We're always going to get a virtual, upright, smaller image, and we don't even really have to draw a sketch. All right, so we know the focal length. What do we want to find out? We want to find the image distance, so that's di. That's what we're trying to find. And we're also trying to find the magnification that results when an object is placed 23 centimeters in front of the lens. So DO is 23 centimeters. And the object distance, we always put that as positive in a single lens problem, so we don't have to worry about whether it's positive or negative. All right, so I know focal length and I know DO. I want to find DI and M. So what are the two equations? Well, they're exactly the same equations that I had for mirrors. 1 over F equals 1 over DI plus 1 over DO. And the magnification is minus DI over DO, or equivalently HI over HO. Okay, so what do I know? I know my DO, I know my F, and I'm asked to find DI, so I can do that with the first equation. And I'm also asked what's the magnification. I know DO, and I'm going to find DI, so that will allow me to find the magnification. So first step, find DI. Second step, find the magnification. All right, so I've got 1 over F equals 1 over DI plus 1 over DO. So I want to rearrange that to get DI by itself. So 1 over DI is 1 over F, and I'm going to subtract the 1 over DO onto the other side. And then to get my DI, I have to take 1 over both sides. All right, so DI is going to be 1 over F minus 1 over DO, and then I'm going to do 1 over that. So DO is 1 over F minus 1. So DI is 1 over F minus 1 over DO. So F is minus 32, and again, it's important that I did that. If I hadn't done the minus, I'd get the wrong number. So because it was a diverging lens, a concave lens, I automatically put that my focal length was negative. All right, minus 1 over DO, and DO is 23 centimeters. And I do 1 over that, so I get negative 13.4 centimeters is my DI. And what does the negative mean? The negative means that it's virtual. And remember, we said that we know for a diverging lens, the image is always going to be virtual and it's always going to be upside right. So we expect if it's upside right, that the magnification should be positive. So now I know my DI. Let me calculate the magnification. Magnification is just minus DI over DO. So it's minus, DI is negative, minus 13.4. DO was 23. So I get plus 0.58. So the plus means it's upside right. And the magnification is less than 1. And so that means that the image is going to be smaller than the object. And again, remember what we said up at the top. For a diverging lens, the image is always virtual, upright, and smaller. And our numbers correspond with that. DI is negative, which means virtual. The magnification is positive, which means it's upside right. And the magnification is less than 1, which means it's smaller. Okay, so again, remember, I always like to draw a sketch. So let's quickly draw a sketch here, just to make sure my numbers came out right. And again, this is more important for a converging lens where we could possibly get either a real or virtual image. All right, so I know that my focal length is 32 centimeters. And my my object is at 23 centimeters. So this is 32 centimeters. My object is at 23 centimeters, so it's closer to the lens than the focal length is. And now I want to draw a picture and draw my special ray. So the first ray, most simple one that I always draw, comes in parallel, and then it gets refracted. So it bends away, and it bends away so that, let's see if I drew this right. Maybe I should draw the other side first. So it bends away so that the refracted ray extrapolates backwards. If I put my eye over here, it looks like that refracted ray came from the focal point. So there's my ray number 1. Ray number 2 is a ray that comes in, looks like it goes through F prime, which is a point that's the same distance away as F, but on the other side. So it comes in. When I say comes in, that means it comes from the tip of the object arrow. So it comes in, and it looks like, again, let me draw the dashed line first so I don't mess up. So it looks like it comes in like it's going to hit that F prime, but then when it gets to the very center of the lens, we bend it and it goes out parallel. So there's my ray number 2. And ray number 3, and this is the very easiest one to draw. It just comes from the tip of the arrow, it goes through the very center of the lens at the black line, the principal axis, and it just continues straight. So you just take your ruler, you place it so that it's going from the tip of the arrow to the center of the lens, and just keeps on going. So if I'm drawing a quick sketch, I usually draw ray 1 and ray 3. Those are the easiest ones. Okay, so where's my image then? Well, my image, if my eyeball's over here, my image is where those 3 rays on, get rid of that eyeball. All right, so it's where, draw my eyeball looking in the right direction. It's where those 3 rays, 1, 2, and 3, appear to be coming from. So my eye extrapolates those 3 rays backwards, and where do they appear to meet? They appear to meet somewhere over on this side, over here. So the light rays really go through onto the right side. So since my image is on the left side, that means it's virtual. And I can see it's also upside right, and that green arrow is shorter than the black arrow, so it's smaller. So I get an image that's virtual, upright, and smaller.